Alrighty, here we go. So, the last time we went over it, we got some things. We did moments, and we calculated the reactionary forces. So we figured out that first we did moments and figured out that RCY was 775. Yes? Yeah. That was the first thing we did, moments. Then we did the sum of the forces in the y direction. And we saw that you had 1,000, 500, 250, all those. We had to add those up, pushing down. We subtract the 775 pushing up, and that meant on the other side, we had to have RAY equals 975. Okay? And we did that. Again, that was just doing the sum of the forces in the y direction. Had to add a 0 because it's not floating up or sinking down. Okay, that would be bad for a bridge. And from there, and when they, like I just said, we just added up, subtracted, and that means that RAY had to be carrying the load at 975 so that it stood still. All right. Then we talked about forces in the x direction, and there were no forces pushing to the right or left besides our RAX. And so that means RAX had to equal 0. All right. Again, doing the sum of the forces in the x direction, but since there's only one force in the x direction, that force has to be 0. So RAX was 0. So that's what we have so far. We have RCY, RAY, RAX. Okay? All right, so now what we have to do is we have to look at one joint at a time. So we can start with joint A. So I would just write off to the side, and I would give yourself a lot of space. All right, off to the side. I'm going to duplicate this thing just in case I have to, well, whatever. Clone page. Clone page again. Okay. Back to that one. All right. So we look at joint A. And what we're going to do is we have to look at that point right there and do the sum of the forces in the x direction, sum of the forces in the y direction. Okay? So, doesn't matter which one we start with. I'll start with the sum of the forces in the y at A. All right? And so what do we got? If you look at the bars, so we have to remember RAY, we have to remember RAX, but we're just doing the vertical right now. So we're going to say sum of the forces in the y direction. We have RAY pushing up. All right. We have the beam that goes from A to D. That has to be split into a vertical piece and a horizontal piece. So I'm going to say ADY. So far, so good? So it's AD, and we're only looking in the y direction, so ADY. All right. And we also know, or we also have the force going from A to B. A to B, and it's not, it doesn't have to be, I'm sorry, that's not in the y, that's in the x direction, so we don't have to deal with that. Okay? So what else do we have? Well, with that, all we have vertically is RAY that's getting pushed up on that joint, and we have AD, the vertical piece. That's the only two vertical pieces we have. Okay? All right. So that means we say that's equal to 0. Well, we already know that RAY is 975. So we can plug that in. We know it's positive 975. All right? If I do my math and bring ADY over, that means it's a minus ADY on this side. So ADY is equal to a negative 975. All right? So this would be something you put off to the side. ADY is a negative 975. Now, when you look at joint A, you have this angle here is going to go, this side is going up 3 over 3. So that's a 45, 45, 90 triangle. Okay? So, if we have a 45, 45, 90, the forces on each side have to be the same. So if I just figured out that ADY, which is this one here, is going to be negative 975, that means that ADX also has to be negative 975. Why? Because it's a 45, 45, 90. Because you have it going up 3 over 3. Okay? So you looked at it and you said, okay, I have a 45 degree. Now, you could do it, and in fact, the teacher solution has it in terms of doing sine, cosine, and all that stuff. We don't need to do that. It's 45, 45, 90. So we know that they have equal sides. But you could do sine, cosine, tangent to figure out what the other piece is. Does that understand that length can transfer to forces? This is the whole idea we learned about vectors. So you can take lengths of triangles, and if they have the same lengths on each side for the triangles, that means they also would have the same forces because it's a vector. That's why we consider a force vector. Okay? So you can take those lengths, and use angles to figure out forces as well. Okay? All right. So now let's do some of the forces in the y direction. If I do some of the force, I'm sorry, in the x. So I'll do a new color. Some of the forces in the x direction. What do we got? Still for joint A. We do this for every joint? Yes, we do. Yes, you're welcome. All right. So some of the forces in the x direction. What do we have? Give me some of the forces. 0. Okay, that's a sum. Good. Give me RAX. RAX. Which is 0, but we'll put that in a second. What else do we have in the x direction? What? ADX. Okay. And AB. And I'll do alphabetical order when I do it. AB. And so those are all our forces in the x direction. Yeah. All right. So those add up to 0. All right. So why is it not ABX? Because AB is only purely horizontal. So AB is purely in the x direction. If you have something at an angle like this, I have to split it into the x and the y. Okay? So you always have to work in terms of purely vertical or purely horizontal. All right? So now we can cross out stuff. ADX is 0. So far, so good? So that means if we do our algebra, we have ADX is equal to AB, or is equal to a minus AB. Okay? I'm going to scroll this down a little bit. So then I can make, and I know that ADX is equal to negative 975. So I have negative 975 is equal to a negative AB, or AB is equal to 975. So what you're doing is slowly picking apart the forces of the beams. All right? So if we work our way back, right here, you know that AB is equal to 975. Okay? Now, what about AD? We know that ADX is negative 975. We know that ADY is negative 975. So what does that mean? How are we going to figure out what actual AD is? Well, think about it this way. We have Pythagorean theorem over here. We have a right triangle. Okay? So it's 975 squared plus 975 squared will give you your answer squared. Whoops, C squared. All right? So we're going to do, if we just do square root of 975 squared plus 975 squared, you'll get your answer squared. I'll pause to do the calculation on a calculator. All right, so we calculate out that this side here, which is AD, is 1378. Whoop, 1378. Okay? So what you're going to do is piece by piece, figure out the piece of each beam. So that's one problem. It had to be negative here. 1378 had to be negative because these two were negative. All right? And what does negative mean? Negative versus positive. Again, I just said it, but RAY was pushing into the joint. That's a compression force. Okay? The other one we have, and that was a positive value. Negative, that means tension. That means it's going to be pulling away. Okay? All right, that's it.